Hello students, for the past two classes we are learning chapter triangles. Hope you remember. So before we get into today's class, I wish to recall what are all the things we learned. We started with the concept of similarity. We have learnt when we will call two figures are similar, right? When we will call two figures are similar, when they have same shape and not necessarily the same size. Two figures are said to be congruent if they have same shape and same size, right? And we have seen few examples and we have stated the criteria for the similarity of triangles. What is it? What are all the conditions? Corresponding angles should be equal and corresponding sides should be in proportion. Then only the two triangles will be said to be similar, right? And we have proved a very famous and a well-known theorem called basic proportionality theorem or Thales theorem. We have proved it and its converse, right? Based on it, we have solved few problems. So in today's class, we are going to learn the criteria for similarity of triangles, right? As we learnt in previous class, in the sense class 9, we have learnt the criteria for two triangles to be congruent, right? Hope you remember. For two triangles to be congruent, it should have the same shape and same size. So every time we cannot check all the 6 parts of the triangle. So we have stated few criteria and we have checked those criteria instead of checking all the 6 parts, right? Hope you remember. The same way in this class, in 10th standard, we are going to find out the criteria for two triangles to become similar. Again, when we call two triangles are similar, if their corresponding angles are equal and their corresponding sides are in the same ratio. So every time it is not possible for us to check all the three angles are equal or not and whether the corresponding sides are in the same ratio. Alright, so we are going to find out few criterias now, and before finding out criterias, as we know, mathematics is full of symbols. We are not interested in writings, right? So we know this is a symbol which we will use it for congruency, and now this is the symbol which we will use for similarity. If we write triangle ABC and this symbol triangle DEF, we mean triangle ABC is similar to triangle DEF. Don't get confused with the congruency and the similarity symbol. For congruency, we will put one wave, tilde like, and then below we will put two lines. If we don't put two lines, it means it is similar. And as we insist on the correspondence between the angles, yes, as we insist on correspondence between the angles in congruency, in similarity also it plays a vital role. The correspondence should not be changed. If we say A is corresponding angle to D, then when you are writing the similarity condition, A should correspond to D, B should correspond to E, and C should correspond to F. Their correspondence should be retained. If you change the order, the entire thing will go wrong, right? If angle A is equal to angle D, B is equal to E, C equals to F, then you should write triangle ABC is similar to triangle DEF only. You should not write FED or EDF as your wish. You should not write, because every vertex corresponds to each other. Yes, hope you remember. Now let us move on to the first criteria for similarity, which is AAA similarity. This is well known to you. What is AAA stands for? Angle, angle, angle. So angle, angle, angle criteria imply that if three angles are equal, if the three corresponding angles are equal in two triangles, then the two triangles will become similar. How? Then immediately their corresponding sides will become proportion, right? Read the statement. If in two triangles corresponding angles are equal, then their corresponding sides are in the same ratio, and hence the two triangles are similar. So what we told, corresponding angle should be equal as well as the corresponding side should be in the same ratio. But now we are going to prove that if the corresponding angles are equal, automatically the corresponding sides will be in proportion. Therefore, it is enough if we check whether the three angles are equal in the two triangles, and we do need not to check whether the corresponding sides are in the proportion or not. Then automatically the two triangles will become similar. right? Now let us see how can we prove this. We have taken two triangle ABC and DEF and it is given corresponding angles are equal, which means we have angle A equals to angle D, angle A equals to angle D, then angle B equals to angle E, angle C equals to angle F, right? And we need to prove that their corresponding sides are in the same ratio, in the sense AB by DE equals to BC by EF equals to AC by DF. This proportion we need to prove. So how are we going to prove this? Cut DP equals to AB and DQ is equals to AC. Hope you understood. We have to cut the side DE at the point P such that DP should be equals to AB and DQ should be equals to AC. Now join PQ, right? Now what will you infer here about triangle ABC and triangle DPQ? This full triangle and this small upper triangle. What you infer, already we know angle A equals to angle D, which is given in the question, and AB equals to DP and AC equals to DQ by our construction. This is by our construction, right? So this is given in the theorem. So by these two, what we infer, these two triangles are congruent by SAS criteria. By SAS criteria, these two triangles will become congruent. This is congruency symbol. If two triangles are congruent, what you know by CPCT, corresponding parts of congruent triangle, the remaining parts also will become equal, right? So what are the remaining parts? Angle B will be equal to angle P, angle C will be equals to angle Q, right? So that's what we have stated here. By CPCT, angle B equals to angle P. But angle B is already equals to angle E, which is given in the question. So from these two, what we infer, angle P equals to angle E. Angle P equals to angle E. Now what do you infer from these? What angle P and angle E denote? These two are corresponding angles. If the corresponding angles are equal, then the lines will become parallel. Therefore PQ is parallel to EF, right? So when a line is parallel to the third side of a triangle, then immediately what theorem will strike our mind? Basic proportionality theorem, BPT. Therefore by BPT, what we know? Corresponding sides are in proportion. So DP by PE equals to DQ by QF. DP by PE equals to DQ by QF by basic proportionality theorem, right? But this can be also written as dP by dE. See, dP by PE is equals to dQ by QF. That's what basic proportionality theorem says. But basic proportionality theorem also says that we have proved a result, right? We can write the full thing by adding 1 to it. Hope you remember, in last class I have explained you. So this can also be written as dP by dE equals to dQ by dF, right? dP by dE equals to dQ by dF. But what is dP? dP is equals to AB and dQ is equals to AC. So we are replacing the numerator by AB and AC. So we got AB by DE equals to AC by DF. AB by DE equals to AC by DF. This is what we got. Similarly, by drawing a line like this, we can prove that AB by DE is equals to BC by EF. Similarly, we can prove this. So from 1 and 2, we infer all the three sides are in proportion. That is, AB by DE equals to AC by DF equals to BC by EF. That's what we need to prove, right? Hence, we proved that. Thus, if in two triangles, if the corresponding angles are equal, then automatically the corresponding sides will become proportional. So the two triangles will become similar. To check the similarity, it is not required to check both the conditions. It is suffice to check whether the corresponding angles are equal. If the corresponding angles are equal by AAA similarity criteria, the two triangles will become similar. Yes, hope you understood. We have done it very easily by cutting the line DE at a point P such that DP equals to AB and DQ is equals to AC. Then we proved these two triangles are congruent, and once it becomes congruent by CPCT, the corresponding parts will become equal. Then we proved these two angles are equal. Then we showed this line is parallel to this. Then we applied basic proportionality theorem. We proved the result, right? Now based on this, immediately as we did in congruency criteria, we can do for similarity criteria as well. By angle sum property, what we know, if two angles will become equal, automatically the third angle will also become equal. So it is not necessary to check whether all the three angles are equal. So from AAA criteria, we can imply AA similarity criteria as well. What does it says? It is not necessary all the three corresponding angles should be equal. It is suffice if any two corresponding angles are equal, the two triangles will become similar. If two angles of one triangle are respectively equal to two angles of another triangle, then the two triangles are similar. This is by angle sum property. Angle sum property of triangle, right? Hope you understood. Let us move on to the next criteria, SSS criteria. Now let us see SSS criteria. If in two triangles, sides of one triangle are proportional to the side of the other triangle, then their corresponding angles are equal and hence the two triangles are similar. So what are we going to prove now? It is enough if the sides of two triangles are in proportion, the two triangles will become similar. It is not necessary to check whether the corresponding angles are equal. That's what we are going to prove by this criteria theorem, right? So what is given? AB by DE equals to BC by EF equals to CA or AC, CA divided by FD, which means the sides are in proportion, which is given in the theorem. We need to prove the corresponding angles are equal. Angle A equals to angle D, angle B equals to angle E, angle C equals to angle F. This is what we need to prove. So as usual, as we did in the previous criteria, we are going to take cut DE at P such that DP is equals to AB and DQ is equals to AC. Now join P and Q, right? Then what we infer? AB by DE equals to AC by DF, which is given in the question. So instead of AB, since we have taken it as DP, we are going to replace AB by DP. AB by DP and AC by DQ. This is by our construction, right? Then this is what we got in the previous step. Now DE, we can write it as DP plus PE. Similarly, DF we can write it as DQ plus QF in the denominator. Now we are reciprocating it, because if we have sum of two terms in the denominator, we cannot do anything, right? So make it as the numerator, reciprocating on both sides. Now split the numerator, DP by DP plus PE by DP. Similarly, here also we have splitted the denominator. This will become 1, this will also become 1. 1 will get cancelled. So we arrived at PE by DP is equals to QF by DQ. Again we are reciprocating it. What we got now? DP by PE. DP by PE is equals to DQ by QF. So immediately what strikes our mind? Converse of basic proportionality theorem. By converse of basic proportionality theorem, this PQ will be parallel to EF, right? PQ is parallel to EF. If PQ is parallel to EF, what we know, the corresponding angles will be equal. Therefore, angle P equals to angle F and angle Q is equals to angle F. P is E and angle Q is equals to F. Since corresponding angles are equal, right? Therefore, what we proved it now, angle P is E and angle Q is F, and already we know D is common. Therefore, by AA similarity criteria, we can tell the smaller triangle is similar to this bigger triangle. Triangle DPQ is similar to triangle DEF. Right? When they are similar, what we know? The sides are in proportion. So DP by DE is equals to DQ by DF, which is equals to PQ by EF. That's what we have written here. Right? But this is what given in the question, actual question. But in this again we are going to replace AB by DP and AC by DQ, because by our construction we have taken it. This term going to retain as such. Right? Here instead of AB we have replaced this by DP, and instead of CA we have replaced it by DQ. Now compare 2 and 3. What you see? These two terms are equal, only this differs, that too only the numerator. Therefore BC should be equals to PQ. Now in this two triangle by construction we know AB is equals to DP and AC equals to DQ. Now we proved BC is also equals to PQ. Therefore by SSS congruency criteria, these two triangles will become congruent. Triangle ABC is congruent to triangle DPQ. Then by CPCT, what we know? All the three angles are equal, corresponding angles. A equal to D, B equal to P, C equals to Q. Right? But already we have proved angle P is same as angle E and angle Q is same as angle F. So we have replaced. That's what we need to prove. Hence we proved the theorem. Right? I repeat what we did. Initially you may feel it confusing, but it's very easy proof. What we did, the same way we have assumed a PQ, we have drawn PQ. Then we have started from the given question. Instead of AB and AC, we have replaced it by DP and PQ. Now we got DP by DE equals to DQ by DF. But to apply basic proportionality theorem and its converse, we need DP by PE, DQ by QF. Right? So accordingly we have added 1 on both sides, or you can subtract. Instead of doing all these things, you can reciprocate and subtract. We have done, I taught you that result in the last class. Yes. So in order to get it, we have done certain manipulations here, and we arrived at a condition DP by PE equals to DQ by QF. Then immediately we stated that by converse of basic proportionality theorem, this line will become parallel. As soon as it's parallel, corresponding angles will become equal. Right? We have stated it aside. Then what we did, once the angles become equal, by AAA similarity criteria, this triangle will become similar to the bigger triangle. When two triangles are similar, the sides will be in proportion. So we have wrote the proportion statement for these two triangles. But already what is given in the theorem, that also we restated it. In that again we replaced it by DP and DQ, because our ultimate aim is to compare this entire triangle with this entire triangle. We have replaced it and we have arrived at a condition that BC is equals to PQ. Once all the three sides have become equal in two triangles, we have stated that again these two triangles. First we told the smaller triangle is similar to the bigger triangle. Now we are telling this triangle is congruent to this triangle. Right? When it is congruent, its corresponding parts will become equal. Right? Its corresponding parts will become equal. Sorry, what we told, this triangle is congruent to this smaller triangle. I repeat, initially we told the smaller triangle is similar to the bigger triangle. Now we are telling this triangle is congruent to this smaller triangle. Therefore, by CPCT, their corresponding angles will become equal. Right? So, their corresponding angles will become equal. We stated that, and immediately by this we are substituting P as E and Q as F. So thus we proved the corresponding angles are equal. So this shows that if the three sides of two triangles, corresponding sides are in proportion, automatically the corresponding angles will become equal. So the two triangles will become similar. So from these two theorems, what we infer, initially we stated that Only if corresponding angles are equal and the corresponding sides are in proportion, the two triangles will become similar. But now we can infer that these two are not the necessary condition. One imply the other. It is suffice if the corresponding angles are equal, automatically the corresponding sides will be in same ratio, therefore the two triangles will become similar. Or if the corresponding sides are in proportion, then automatically the corresponding angles will become equal, and hence the two triangles will become similar, right? The next criteria is SAS criteria, as we had in our congruency. What is SAS? Side angle side. So what does this imply? If two corresponding sides are in proportion and the included angle are equal, the two triangles will become similar. That is, if AB by DE is equals to AC by DF and angle A equal to angle D, which is the included angle, then the two triangles will become similar. Actually, SAS been an axiom in our congruency, but here it is theorem. We can prove it very well as we did for the previous theorems. I am not doing the proof here. Hope you can understand. You can do it by your own as we did the previous proof, right? So with this, let us wind up today's class. So what we learnt in today's class, we have learnt all the three criteria for two triangles to be similar. AAA criteria, which implies AA similarity. Then we have learnt what is SSS, and last one is SAS. So for two triangles to be similar, it is enough if all the three corresponding angles are equal, or any two corresponding angles are equal, or else all the three sides should be in proportion, or else two sides and the included angle are equal. Two sides should be in proportion and the included angle should be equal. Then the two triangles will become similar. So in the next class, let us solve problems using these criteria. So go through all these things, learn it once again, all the criteria. Thank you, students.